Welcome to Python for Introductory Statistics. In this video, we'll learn how to do a chi-square test of independence. Let's look at this example. This example is from a textbook by Larson and Farber. It says that the contingency table below shows a random sample of white, black, and Hispanic college students based on whether their family borrowed money to pay their college education, and then test the hypothesis that borrowing money to college and race are independent. So the way we read this contingency table is that for the white race, 49 said yes, 64 said no. For the black race, 85 said yes, 123 said no, and so on. So now what we will do is we will go ahead and first we could just each row. So let's call this R1. The first row can be entered as 49 comma 64. Let's call it C1. Okay, so C1, 41, and 64. Okay, and then C2 will be the second row, which is 85 and 123. That's how we're going to enter it into our Google Colab here. So let's import first. We're going to need the SciPy. So from SciPy, import stats. And now all these columns, let me save time by copying it here. Right? So let's copy all those values here. Right? So these are each of the rows, row 1, row 2. We could use R if R is better to sound. Row 1, row 2, row 3. Now, not 33, but row 3. Now we will put all this together and we'll call them, these are the observed values. This time we don't have to calculate the expected values ourselves, but the observed values will contain the first row, R1, R2, and R3. And all of those R's are defined here. And now we're done. We'll just call this function. It's from SciPy, and it's under stats. So we'll call it stats, and then chi-squared. I think chi2, I believe, underscore contingency. There it is. So I'll copy this, make sure I don't make any spelling error, and then we will give it the observed values. Now let's run this. You will see that because there are 4 output values, it may ask us to identify them. If we just run this, then we'd have to remember the first number is the chi-squared test statistic, right? So the chi-squared test statistic for the goodness of test is 5.99, and then this 0.0499 is the p-value, okay, the p-value. And then 2 is the degrees of freedom, which is found by the number of rows minus 1 times the number of columns minus 1. And the last one is the expected value, which we don't need it, but it calculated it for us. So in order to remember this, the first number is, so we could do it this way. We could add, the first one is the chi-square test of statistics. Second one is p-value, right, p-val. And the third one is the degrees of freedom. And the last one are the expected values. Now, if we do it this way, and then we print it one at a time, then we'd know exactly what is what. So print chi-squared, right? And then we could say print p-value. Actually, those are the only thing we need, p-val, and we don't need the other two. So if we print this two, now it becomes clear that the first one is the chi-square test statistic, and the last one is the p-value, and we can make a decision based on this, whether to reject or not to reject.